0.1. Then you're going to multiply that by this number here, 0.02. So to make it easy for yourselves when you're studying this, you can just draw an arrow that you put this number here, you put this number here, and you put this number here. And you're always multiplying it. Okay, by the way, this line here means that you divide 97 by 0.1. Okay? So you take your calculator and you divide 97 by 0.1 and then you multiply it by 0.02. So let's do it. 97 divided by 0.1 gives you a number, which is 970. Multiply that number by 0.02. That gives you an answer of 19.4 feet. 19.4 feet. Now, once you have that number, you're going to go back up to these numbers here, and you're going to go to the conversion factor of the lower number, which was the 28.20. That's always going to be in B. So you write that number down, 1630, and you minus this number that you just found, which is 19.4. So let's do that. It's 1630 minus 19.4 gives you an answer of, if you can see that there, 1,601. So I rounded it up. It's 0.6, but I rounded it up to 1. So it's 1,611 feet. So what that is that's our pressure altitude conversion factor. So if on the chart they actually had an entry for 28.22, we know that it falls between 1630 and 1533. The number that would be here on the right side would be 1,611, which indeed is between 1533 and 1630. So that is our pressure altitude conversion factor. Okay, just again, memorize this for now. It'll make sense later. All right. So once you have that number, all you have to do is add the conversion factor, 1,611, to the indicated altitude they gave us in the question, which was 1,380. So we're going to add 1,380 to our pressure altitude conversion factor. And that comes out to 2,991 feet. 2,991 feet. So that is our pressure altitude. And the question here is asking us to determine the pressure altitude. So let's see if our answer matches any one of these. I have 2,991, and if you look at answer B, 2,991 feet. And let's see if B matches. And that is in fact the answer, 2,991 feet. So we know the pressure altitude. Now the question does not ask us to find the density altitude, but let's assume we did want to find the density altitude. We would go up to this chart here, and we know from the question that we're at standard temperature. So what is standard temperature, folks? Standard temperature in Fahrenheit is what? That's going to be somewhere on your test or your check ride. You're going to need to know that. It's 59 degrees. That's something you just memorize. 59 degrees Fahrenheit is standard temperature. So we know the standard temperature, it's 59 degrees. We know our pressure altitude from our calculation is 2,991 feet. So what you do is you go to your chart and you look for the pressure altitude that corresponds to 2,991 feet. Now, this chart is way too small to be able to see or find 2,991. So I think it's close enough to 3,000. So I'm just going to use the 3,000 pressure altitude line here. So if we were to go to 59, so here's the 60, that's close enough. Go from the 60 all the way up to the 3,000 and see where that intersects. And that's about one box up from the one box up from this major line right here, this heavy line here. So it's not quite 3,500. So we'll just say it's 3,600. So if we needed to find the density altitude, which this question doesn't ask for, it would have been 3,600 feet. That would have been the density altitude. But they didn't ask for it in this question. So the answer to this question is just pressure altitude. Pressure altitude, 2,991. Now I know that sounds a little confusing, but I'm going to give you a formula sheet to follow. And I'm going to show that to you now. Do not be intimidated by this. This is a worksheet I created to solve these pressure altitude problems. You're going to insert your altimeter settings into this box here. You're going to write to the right of it the pressure altitude conversion factors after looking it up on your table, which is right here. You'll take the difference between B and C, and you'll get something that I call D. Then you'll do A minus B, which is this one minus this one. Then to the right of it, you'll do C minus B, which is this one minus this one. And you'll get an answer, which I call E and F. Then you're going to look for G. And G is found by simply taking whatever number comes into D here, dividing it by whatever number becomes F here, and multiplying it by whatever number becomes E here. Once you have that, you have G. Then you go up to the top here, whatever number was in B star right here, whatever was in B star here, you're going to subtract the answer in G. So that B minus G gives you something we call H. Once you have H, you just add it to the indicated altitude, which is given in the question, and that becomes your pressure altitude. I know it seems like a lot, but it's extraordinarily easy. Very, very easy once you've done it a few times. And we'll do that in study class, and I'll put a few more of these up online as time permits. So keep practicing, try it out. You'll see. At first, it's going to take you 20 minutes to solve a problem. But your second problem is only going to take about 10 minutes. And your third problem will only take about 5 or 6 minutes. And as you're doing the problem, you're going to understand, if you spend the time to process the information, you're going to understand what these calculations are actually telling you as you go along. But for now, this is enough for you to get the right answer on the test, which is all the FAA cares about at the point you're doing the written. So practice, practice, practice.